This module has been packed with information about parallel programming. Hopefully, you've got a good understanding of when it's appropriate for you to use parallel programming in your applications. This means understanding the implication of introducing things like parallel for each, or parallel invoke. If you're working in ASP.NET, it's really important to make the conscious decision that this is something that you'd want to use in your code. By now, you know the difference and similarities between parallel and asynchronous programming. The big difference is that with asynchronous programming, you schedule a continuation to handle the result of the concurrent operation. The methods we've explored in this course all depend and build on top of the task in the task parallel library. You can use the task parallel library to introduce both asynchronous and parallel principles in your applications, which makes this an extremely powerful toolkit when you write your code. Remember that all of these different principles work in any type of C# and .NET application. Although, if you're working on a microprocessor that's using .NET, like a coffee machine, or something that only has one core, maybe using asynchronous and parallel programming isn't completely necessary. We introduced parallelism in an application with the help of the task parallel library, which is an extremely efficient way for you to break down a large problem into smaller pieces that are all solved independently. This saves you from managing the tasks, threads, and computing how many cores there are available for you to construct the ultimate parallel execution. The task parallel library and its parallel class does this for you. It distributes the workload in the most efficient way possible. You could now even configure the execution to lower the maximum amount of concurrent tasks. That will be handy in the cases of you not wanting the application eating up all the available resources. We introduced the concurrent bag of tea to allow for an aggregated result. This provided a thread-safe collection that each parallel operation could add data to. Most important of all, you learned how to take a big chunk of data, split that into smaller pieces, and run computations concurrently. Because the parallel class and its methods block the current thread, we saw how to use parallel and asynchronous principles together. You simply wrap the operation in a task.run, although when doing so, you're also not using the full capabilities of the available threads. This is the right call, especially in a UI application. If this was a console application, that would be a completely different story. Next, we are going to dig into the advanced topics and cover shared variables, locking, deadlocking, and canceling parallel operations, as well as parallel link. There's much more to cover, and you're off to a really good start.